Fine, fine. You do some assumptions. No, he has not given. Okay, I'll agree. He has not given. I'll agree. Write it here. Now start the problem. So the area of cross section. This is S1. This is S2. This is S1. This is S2. So the liquid is there of the same density, rho, and rho. Till here, okay. What all that is there? I think I just do the same thing. I just do the same thing. Okay. Now I'll place a block. So when I place a block, what do you expect? When I place a block, what do you expect? The level of liquids will change, no? The level of liquid in one container will increase, the other, and is telling capital M greater than small m. So capital M is brought on left hand side and small m is placed in the right side, right hand. So two containers are there. So which piston will move? So we'll call this as piston B. This is piston A. I'm going to place block M in this direction and this will be in this direction. That's same initially this much. I think I'll give one more diagram. So that will be after placing the blocks. Now will immerse a block. Let me put a block here, no, first. So what will be the level of liquid? Level of liquid earlier it was having some level. That the initial level. Yeah. So definitely the level of liquid should rise. So the level of liquid will rise. So the rise in level of liquid I'll show by green color. Liquid will not change its color, only rise in level of liquid. So that rise, I'll call it as X. Actually, I should move this down since like again, drawing diagram will take more time. So I'm adjusting it here only. Level of liquid in the, because capital M is less than small m. I'll adjust the diagram. You'll understand very easily. The diagram is what very important here. Now the small m is brought it here. No, small m is brought it. Mass of this will be. So initial level of liquid was this much. Here the liquid has rised. Okay, call this is. So the difference in level of piston. I will show the complete everything picture. No, okay, no. Anybody, I think, looking at diagram, anybody can solve this problem, or anybody. You need not be any intelligent also. Okay, just bring the basics of buoyancy. Bring the basics of buoyancy. What is that? Uh, what is the state of the blocks? Are they in equilibrium? Yes, they are in equilibrium. So when they are in equilibrium, let's write one more thing and also. What are the buoyant force? FB1 will act here. And its weight will act. No? Similarly, a buoyant force will act here. Will agree this. So what is FB1? By this liquid on the block. Similarly, the block will also exert force. That I'm showing it here. Agree this? Similarly, now come for this one. FB2 small mg here FB2. Write it now. So write the equation. So I'll move from A. I'll move from A. So what is FB1? FB1 equal to M1G first. FB1 is equal to mg. FB2 is equal to small mg. So let's write pressure equation. FB1 into area of cross section of the piston S2 pressure minus rho GH, because I'll move like this. Huh? What is the gauge pressure here? FB1. So atmospheric pressure you neglect it. P naught A. You not to bother. Anyway, it will cancel out. Okay, let's for your convenience I'll write it. Huh? Make problem very simple. Okay, now start here. FB1 by S2. Then you move down and you rise up. That will cancel out now that gauge pressure. So directly from here minus I'm rising up inside liquid minus rho GH. What is the gauge pressure here? Minus where you end up minus FB2 S2 equal to this one. So what is FB1? Mg. What is FB2? Small mg. This one. So what is the expression for H? M minus small m. So this they find the difference in between level of pistons of area S2 in two cylinders. Okay, what is the only concept? The liquid will exert force on the block, FB1. In turn, the block will exert force on the liquid. That is FB1. Liquid will exert force on the block, smaller block, FB2. In turn, the block will exert force on the liquid, FB2. That FB2 will act on the piston also. Next, after the difference in final level of pistons of area S1 here is asking in the beakers. What is telling? They are cylindrical cups. This is cylindrical cups. What is the difference in level in cylindrical cups here? So what is asking? What we should calculate? Difference in levels of cup. From where to where I should write equation? P naught equal to 0. Cylindrical cup. I'll write it because this is the cylindrical cup. A problem little bit diagram based. It will take time because there is no any other equation. No, directly. So what is R? R I should measure from here to from here. What is, shall we write any equation? R plus X plus L should be equal to H plus L plus Y. Look at the geometry. So what all we can write it as? R plus X plus L should be equal to Y plus L plus H. L gets eliminated. So R plus X equal to Y plus H. Okay, now H we know. X and Y we don't know what to do with X and Y. X and Y is the rise in the level of liquid. Rise in level of liquid, or shall I say equal to the volume of the rise in level of liquid in both the cylindrical cups. How to calculate that? Same buoyancy. So what is this buoyancy? You can write it now. The same buoyancy you can write it as rho into area of rise in level of liquid x1 into g. Sir, but area of cross section, definitely what happened? The area of cross section of block will be very much small than that of the cup. So we can write it here. So what is now FB1? FB1 is equal to mg. So therefore, what is x is equal to m by rho s1. Similarly, I need one more page here. I'll start with this diagram. Okay, we'll write in next page here. All. Finally, we have to substitute things here. Looking at this. So what is FB2? FB2 should be equal to rho y s1 into g. And what is FB2? FB2 should be equal to small mg. So therefore, what is y is equal to small m by rho s1. Let me substitute all these things. So finally, we have to get expression for r. No? So r plus what is x? M rho s1. What is y? Small m rho s1. And what is h? M minus m by rho s2. I think really very good problem where student have to fight with a diagram. Huh? So I've seen most of the students, what they do, they go for random writing equations without diagrams. Nobody can help. And later on, they come to know, sir, how you're writing equation. I think so from diagram, see how much I struggle to draw the diagram before. So do put effort. There's no something very big concepts here involved. And the geometry should be very neat for you. The analysis should be very neat. Nothing, so no big mathematics you can see. A clean observation, very clean observation is needed. I'll scroll down to the next concept. Problems later on we'll discuss. Okay, now, if a ice floats, half an hour is there, we'll just I'll come back this one.